Hello. This time we're going to go over this problem about linear algebra, where we want to find the solutions to the system that we are stating here. So, the first thing that I will do is make a transformation. Transform this into a matrix. What is a matrix? Well, it's just a rectangular array of numbers. So, in this case, what I'm going to do is represent each of the columns by the unknowns associated to the system. So the first one will be the column of the x, the next one will be the column of the y, the next the column of the z, and the last one, the one that is associated with the constants that are just circling here. Okay, so what are the coefficients associated with this system, right? Well, this one is -1, -8, 1, 0. Followed by 2, 16, -2, and 0. Okay, well, the intention is to reduce the system so that we can easily read off the solutions. And to do that, I'm going to perform a series of elementary row operations. And the first one is to make the first entry in the first row a positive one, to make it into a pivot. So that will turn the matrix into something that looks like this: 1, 8, -1, 0, 2, 16, -2, 0. Now, the process of elimination says that once you select a pivot, you want to eliminate every single element in that column, right? So since this is our pivot, we want to get rid of these two. So how do we do that? Well, to row number 2, we subtract 2 times row number 1. And we obtain the following: 1, 8, -1, 0, 0, 0, 0, 0. Right? So, one would wonder, well, what does this mean? Well, a column full of zeros indicates, right, that what we have written in this, what we wrote in the system, contains some level of redundancy. There are equations here that are not needed for us, but that is indicated right here. The original system is redundant. It doesn't say that it has infinitely many solutions. It says that one of the equations was not necessary, right, to capture the solutions. So let's go back, right? Let's recover the system, right? Why? Because this column full of, this row full of zeros indicates that 0 is equal to 0. Well, tell me something new. Okay, so next, we recover it. We have x plus 8y minus c equal to 0. From here, I'm going to make a transformation, and I'm going to write this as x is equal to -8y plus z, right? Now we see the importance of having the system in a reduced echelon form, right? This is a vector x, y, z, meaning 3 numbers, right? In this case, is a solution if and only if the entries on that vector, which is nothing else but a column matrix or a row matrix depending on the situation, is -8y plus z, y, and z. So that leaves freedom for us to indicate that y and z could be anything that we wish. But just wait for a second, because I'm going to produce a kind of like more elaborate version of this vector. So now I'm going to transform this into this fashion: -8y plus z, y plus 0z, 0y plus 1 times z. Of course, these two objects are identical, right? And these conditions that we have here are drawn from this equation. Okay, next, I'm going to make a decomposition. So I'm going to break this into two pieces. One containing only the y's. So that would be negative 8y, 1 times y, 0 times y, plus z, 0 times z, 1 times z. Then this one will be decomposed as y times negative 8, 1, 0, plus 1, 0, 1. Because as you may say, you have a 1 here hidden, times z. Look, what this says is that y and z can be any real number. This means the following. This means that every solution, that for every s and t real numbers, we have that x, y, z equal to s times negative 8, 1, 0 plus t times 1, 0, 1 is a solution to the system of equations. In other words, what we have done is that we parameterize the collection of solutions by these two numbers. I hope that you enjoy it. Take care.